Welcome to the explainer. Every time you step up to a sink, turn on the tap, and lather up your hands, you're actually kicking off this absolutely fascinating microscopic chain reaction. Today, we're exploring the molecular mechanics of soap. What seems like honestly the most mundane daily task in the world is literally a masterclass in chemical engineering, and it's happening right there on your skin. Okay, let's dive right into this. Have you ever tried to wash greasy, dirty hands with just plain water? Think about working out in the garage or, just eating something really oily. You can scrub and rinse all you want, but the water just beads up and rolls right off the grease. It's so frustrating, right? Well, the reason for this everyday failure is fundamental. Oil and water simply do not mix. They are totally chemically incompatible. Water molecules love to stick to other water molecules, and they essentially just ignore the oils that are trapping the dirt on your skin. So, without some sort of chemical mediator, water alone is completely powerless against that stubborn, oily grime. But then, enter the hero of our story, the simple soap molecule. The moment you add a lather of soap, it completely changes the entire dynamic of this aquatic environment. It's a real game changer. Soap is deeply fascinating because it behaves as if it has two distinct personalities bundled into one tiny structure. It acts as the ultimate microscopic diplomat between two stubborn substances, oil and water, that absolutely refuse to cooperate on their own. And this dual personality works beautifully in practice. Think of the basic anatomy of a single soap molecule kind of like a microscopic tadpole. On one end, you have the hydrophilic head. Hydrophilic basically translates to water-loving. This part of the molecule is deeply chemically attracted to water. But on the exact opposite end, you have the hydrophobic tail, a water-fearing end that absolutely loves to bond with oil and grease. This unique split personality structure is the critical secret weapon. It completely bridges the massive chemical gap between the grease stuck to your hands and the water pouring out of your faucet. Now, when thousands of these dual-natured little soap molecules hit the grease on your skin, they instantly spring into action. Their oil-loving tails burrow deep down into the grime to escape the surrounding water. And at the exact same time, their water-loving heads point outward, trying to stay in contact with the water. As they do this, they pry the grease right off your skin and arrange themselves into this highly organized spherical structure called a micelle. Imagine it as a perfectly engineered molecular trap. The dirt and oil are caught dead center, totally surrounded by a protective, outward-facing shell of soap molecules. So, how does this microscopic trap actually get your hands clean? You can really think of these soap molecules as a coordinated, tiny rescue team working right on the surface of your skin. The sequence is beautifully simple. Step 1. The hydrophobic tails reach in and grab onto the grease. Step 2. The outward-facing hydrophilic heads hold tight to the flowing water. And Step 3. Together, they pull. Because the entire outside of this micelle structure loves water, the water flowing from your tap can effortlessly sweep the whole shebang, grease, dirt, and all, right down the drain. The chemical mediator has successfully done its job. It grabbed the enemy and dragged it entirely away. But wait, the power of this tiny rescue team doesn't stop at just moving harmless dirt. It is highly, highly effective against microscopic threats, too. Many germs, including certain viruses and bacteria, are protected by an outer shell made of lipids. And lipids? Well, that's basically just fat. So the soap molecule's oil-loving tail wedges directly into the lipid shell of the germ, prying it apart and completely disrupting its structure. It doesn't just wash the germ away. It literally dismantles it right there on your hands. No way for it to survive that. To truly appreciate this invisible battle, we really have to look back at the scientists who figured out how these molecular films operate in the first place. A key pioneer here was Irving Langmuir. His groundbreaking study of surface chemistry gave us the exact blueprints to understand how oils, water, and molecules interact right at the surface level. Scientists like Langmuir provided us with the essential framework to understand the invisible, everyday forces keeping us clean and safe. When you zoom back out from the microscopic world and you're just looking at your perfectly clean hands under a running tap, it's honestly a humbling realization. Soap is such an ordinary, everyday item, yet its fundamental chemistry is powerful enough to change global public health. This incredibly simple molecular reaction has saved countless lives throughout human history, quietly and effectively protecting us, one tiny micelle at a time. Which brings us to the end for today, leaving us with a truly fascinating, provocative thought to chew on. If a simple, almost completely overlooked soap molecule, Something sitting on the counter in literally every single kitchen and bathroom on Earth can perform such incredible chemical feats and completely transform global public health. Well, what other microscopic miracles are quietly hiding in plain sight in your daily routine? I really hope this has changed the way you look at something as simple as washing your hands. Keep questioning the ordinary, keep learning, and I'll see you next time.